Okay, let's go ahead and take a look at separable differential equations. Okay, what I have here is I have listed all of the integration techniques that we know. We have the U substitution, the trig substitution, and the most recent one is integration by parts, which we know is an inverse of the product rule and used for integrals involving the product of two transcendental functions or a polynomial times a transcendental function. Okay, so what we're going to do then is all of these techniques, of course, are going to really help us in terms of solving what are called differential equations. Okay, and not all differential equations are separable, but what we'll do in this particular course is look only at those that are. Okay, so let's go ahead and get an idea first of what a differential equation is. Okay, here's our definition. It says a differential equation is an equation that involves the derivative. When you implicitly differentiate an equation, the result was a differential equation. Okay, so the result of implicit differentiation is going to give you basically a differential equation. Now, to solve for a differential equation, what we need to do is we need to go ahead and separate the variables. That's one technique that's there. And we're just going to be focusing on those type of differential equations that we can actually separate. Now, let's just go ahead and take a look at an example. Let's say, for example, we have this differential equation, because notice it involves a derivative. It says d of z over d of r is going to be equal to z times by 1 plus r squared. Now, if we were to go ahead and take a look at this particular equation here, what we can do is if I go ahead and divide both sides by 1 over z, and I also go ahead and multiply both sides by d of r, then what I have is 1 over z, d of z is equal to 1 plus r squared d of r. So notice that what we've basically done is we've taken all the z variables and associated with the differential d of z, and we've taken all of the r variables and those constants that are associated with it onto one side and associated also with the d of r differential. And then what we can do is we can integrate both sides. Okay, and so what we come up with here is just going to be the natural log of the absolute value of z is going to be equal to r plus 1/3 r cubed plus c. Now notice that what we have right now is we have a general solution, and this is going to be the general form, of course, because we have the constant of integration c involved in our solution. Now let's say, for example, though, that we're given a particular value, a z of 0 is equal to e, and if we go ahead and use that information to solve what c is, and in this case c is just going to be simply 1, then we can go ahead and come out with the value of the particular solution to this differential equation. So if I was to go ahead and take the natural log of the absolute value of z is equal to r plus 1/3 r cubed plus 1, and then I can go ahead then and solve for z, and notice I come out with the z of r function being equal to plus or minus e to the r plus 1/3 r to the third plus 1. Okay, and so basically what happens then is that if I was to go ahead and differentiate this with respect to r, I would basically be able to come out with exactly that form there. So what's going to happen then is we're going to come across a lot of different types of differential equations that we'll be able to separate, and then what we have to do is we have to integrate both sides of the equation, and in order to do that we need to use some of our integration techniques that we know. Okay, so we'll go ahead and take a look at some of these problems in class. We'll take a look at some of the ones that will be much more interesting because of the richness of the integral and the various techniques that you need to use, and we'll go ahead and practice those in class. So give it your best shot. We'll take a look at some of these problems, and hopefully everybody will be able to solve these separable differential equations. Okay, so see you next time. Bye-bye.